Welcome to the course of Network Protocols. I'm your instructor Zeeshan Bangash. Today, in this lecture number 17, we will be discussing Internet protocol stacks, particularly the network layer protocols. So, let's move to the outlines of our today's discussion. Today, we will be talking about some network layer basics and we'll try to review our basic knowledge about the function and operation of network layer. We will be talking about some routing algorithms and some routing mechanism on the internet. We will also be talking about hierarchical routing algorithms and at which level these routing algorithms are used. And we will also be talking about the internet addressing format and its purpose. We will talk about some network service model that is used in most of the network application for communication, for audio and video streaming. And at the end, we will summarize some of the functionality or particularly the complete functionality of network layer. So let's talk about the network layer and its functionality. Why it is kept as a separate layer, and we already know that most of the communication and the packet switching and the hop to hop movement is the responsibility of this layer. So based on its complication, it have been designated as a separate layer to perform its operation. So we know that to one host there are multiple connection, whether it's a source or a destination. So this layer is responsible for managing the multiple connection to the host. And we already know that there is no direct connection or no directly link between a source and destination. So a number of intermediate hosts or intermediate nodes are involved in communicating a message or a data from source towards its destination. So this layer is responsible for forwarding that data or message from the intermediate nodes, passing it through the intermediate nodes that might be switches, bridges or routers towards its destination. And we already know that in an internet environment or the communication environment or the topology is not fixed, so the links are active and disabled based on the topological changes. So the route toward the destination is always not static. So during the communication, the route and the topological changes. So for that, this layer, network layer, is responsible for managing that topological changes. Also, this layer is responsible for interfacing with the upper layer, which is the transport layer, which is responsible for segmentation of the data or the frames. So it also interfaces itself to the transport layer, where the destination address are packed. The network layer functionality includes some routing algorithm services and the service model to the transport layer for communication, and it passes data or packets to the transport layer if it reaches towards its destination. However, at the intermediate level, the network layer, after performing its operation, pass it to the neighbor node to forward it towards the destination. However, if it reaches towards the destination, so at the network layer on the same destination, the interface toward the upper layer, which is the transport layer, the data is moved to that particularly transport layer. So network layer functionality includes the routers and the routing algorithm. So in the diagram you can just notice that there is different networks, or we can call nodes, that are interconnected to each other. So we We can just know that the uh, node A, B, C, D, F, and all these nodes are interconnected to each other. So we can view it as a graph or a perfect example of an internet where therefore between a source and destination there are multiple paths. And you can also notice in the diagram that each link between two nodes, a weight is shown on the path. That is basically the cost of that path. So if the data is moved from, for example, a to b, so the cost of that route is 2. This weighted graph shows uh, the cost of each link between two nodes. So if we are moving from uh, node A to node F, so there is no direct connection or direct link. There are intermediate hosts that are involved in the communication. For example, if you can just notice this, that from A, one of the path is moving from A to E and then from E to F. So if we can notice the weight or the cost of that route, so that cost comprise of that cost from A to E, which is 5, along with that cost from E to F, which is 6. So the total route cost from A to F is 6. So the same thing is shown in the upcoming slide as a table, in which you can just notice that if we can start from the node A, and if you want to reach toward B, so this route AB have a cost of 2. So this matrix shows the details about the cost of each link. Similarly, if you are at A and you want to reach C, so the cost of route AC is 1. And similarly for D, E, and F, and there is no direct cost of the route from A to F. Now, among this, if you can just notice it, that for among this route cost, this AC is the least cost if you are at the A and moving toward any of the link. Similarly, if you just look at this AC, so the different costs that are shown from reaching to the multiple nodes, because most of the nodes are connected, or every node is connected to at least every other node directly or indirectly. So this shows a routing table in which the details about the cost of that link from one node to another node is shown. Now there's another example, another table which we called distance vector table, and you can just notice that we want to reach node E in the previous diagram from that node O. However, this table is a distance vector table in which detail is shown. So just look at that. Uh, Again, this is a matrix, because since we are reaching to E from node, so you can just that it's a matrix that comprises of A, B, C, and uh, F, right? Similarly, there's another column that shows the same matrix A, B, C, D, and F, and we are trying to reach the destination, which is E. So if you are at A and if you want to again reach to E using that link A, so the total cost, if you can look at that diagram, is 5. Similarly, if you are at node A and you want to reach E, and that intermediate node is through B, so the cost through the link BA is 3. So similarly, the whole distance vector table, or we can say that the routing algorithm following the distance vector technique is shown in the diagram. Now, basically, when you consider a network or an internet, we can call it a network of networks. There are thousands of millions of networks that are interconnected, and that can continuously increase with the passage of time. So the number of networks from few hundreds to few thousand on the internet, or to few millions, that is a very huge group of networks. We call it an internet. So the routing mechanism or the good routing algorithms are very much important. So there are two levels of routing that can be performed on the internet. One is the inter-network routing within the local area, or within a particular area, a routing that needs to be performed. And similarly, there is routing among the networks. We call it uh, intra-network routing. So there are different type of algorithms that are used for both the scenarios. So just look at that. Autonomous systems are basically those systems that are allows evolution, and they are basically the gateways. There are gateways that are defined in that networks, and that's used for inter-routing. So basically this network layer, which is basically the third layer of the OSI model, the routing algorithm, that is basically the functionality of this layer that can be used for communication among the nodes that are in the same network, or they can be used for the communication among the nodes that are across the different autonomous systems. And they this routing algorithms that are used for communication among the different autonomous systems provide integration. Now, let's consider this scenario in which this is one autonomous network comprised of different networks. This is another autonomous system, and this is the third autonomous system. And in this autonomous system, we can just notice that there are different inter-network routing in this autonomous system. Similarly, there's inter-network routing and inter-network routing in each autonomous system. However, there is a gateway through which one autonomous system is connected to another. So you can just look into that. So for these gateway intercommunication, this border gateway protocol, which we call it as a BGP protocol, is used. And basically it's a hierarchy routing algorithm, and that can be used at multiple levels. So this BGP algorithm, which is a routing algorithm, that is used at the core level for inter autonomous system routing. So now let's talk about the telephone addressing. So the telephone number which we use personally in our home has a format, and this format comprises of the area code and the exchange code, and followed by some unique identifier. So you can just look into that the normal telephone number comprise of 10 digits, in which the first three digits shows the area code, and then that is followed by the exchange code, and at last a four digit number shows the device number. However, this number of digits is not fixed to any particular standard. Every exchange of a country, or the central exchange, follow a different number of digits to represent its telephone numbering system. However, as an example, it is shown. Similarly, if we talk about the internet protocol addressing, or we can call it an IP addressing, so it has two parts. So the first part is basically the IP network addressing, and the second part is basically the host or the device addressing. So that address is basically comprised of two information. One is about the network information, and one is about the device information. So the total number of IP address bits, or the size of IP address, is basically 32 bits, or we can call it 4 bytes reserved for internet or IP addressing, which is divided into two part. Some part will be will show the network addressing, and some bits, number of bits, will show the host addressing. So how much bits represents the network part and how much bits represents the host part, that depends again about depends based on the scenario, that how your network will, or the topology will look like. So let's consider this, that it's a 32-bit address. You can just notice this, that this is a 32-bit address. However, as we have known it from the previous knowledge, that basically it comprises of 4 octet. So the first 8-bit comprise of the first octet, then the second 8-bit, and the third 8-bit, and the fourth 8-bit. So that's completely 32-bit IP address. So now if we want to convert this into a numeric shape or a digital shape, so each 8 bits octet is converted into a decimal number, and it can be represented as shown in the figure 128.61.23.216. Now in this addressing, the first 24 bits, which we can just these 24 bits, they are the network part, and the last octet bit, which is 6 by 24, it's basically is the host part. So how we can identify it, that for which part of the network should be the network bits, or which part should be the host bits. So for that, a standard has been shown, in which we know it from the previous knowledge of data communication, that the IP addressing based on the some standards or some address fixing has been categorized into class A, class B, and class C addresses. So currently we can just see this, that is basically an example of class C IP addressing, or class B, or we can call it a class C IP addressing. So we can just review our basic understanding of that. So how many IP addressing? So you can just look into this diagram, that there's an internet, and then it's connected with a router, and this router is connected with a local area network, and then this local area network is connected with different computers having different IP, and through this link it is connected. So this local area network connecting with an IP is connected with this address, and then through this is connected with an internet. So you can just notice that different IPs. However, in the one local area network, a same scheme is followed for assigning address to different hosts. Now similarly, look into the diagram, that in one local area network, the different hosts are connected following one scheme, and then that is connected with a router, and this router is connected with another router. So there's a router to router communication, and if they are at a different autonomous system, so the BGP protocol can be used for inter autonomous system communication. And then there's another local area network in which different hosts are connected, and they are again connected with a router or a bridge or a switch. So this is an example of how the IP address has been assigned to different hosts, or to a particular interface of the intermediate node, which we call as a router or bridge or a switch. This is an example which is known as a class A IP. We call it a class A IP, in which the first 8-bit comprise the network. It's basically an example of class C IP. It is class C IP, in which the last 8 bits are the device address, and the remaining part is basically the network address. This is basically example of class B IP, in which the number of bits for network part is same as the host bit. Similarly, let's look at the another class, which is basically class C IP, in which the number of IP or the network bits are 24 bits, and number of host or the device bits are 8 bits. So we can just review from the basic understanding which we discussed in the course of data communication in network about the classes of IP addressing. So we can just consult that topic for further details. A perfect example of a network service model we can show it is the switching. We can just know that we know that there's no fixed or allotted part between a source and a destination, or a permanent link. However, in internet, when we are using any application like any communication that is used for uh, inter nodes, just like uh, a Zoom software or a team viewer, in which we know that we can't tolerate delay, but we need a sort of permanent communication and bandwidth. So a sort of circuit switching network, in which first of all the source sends a initial packet to the destination, through which the route is known, that this will be the route through different intermediate nodes, and then that route is basically followed by all the uh, remaining nodes. So circuit switching is basically a sort of that model, in which a sort of a circuit is created between a source and destination, and the packet is moved using that network layer or that IP protocol towards its destination on a fixed path for some duration of time. So this is a network service model for a better communication. Similarly, for message switching, you can just look into it, that the data that is originating from the source towards the destination, that passes through different routers while reaching towards the destination, and the message through that timeline passed from one router to another router. And we can just look into another diagram in which the message breakup has been shown. That just look into it, that the data that is generated from the source comprise of many packets. So it's when once reaches this router, from which the three packets are moved toward this router, and the one packet is moved to somewhere else, some other interface. Reaching at these three packets at this router, two packets are moved to this link, and one packet is moved to some other interface of this router, and through that two packets move to that link, the destination packet reaches toward the destination, which is the receiver address. So this is a summary in which details about the network layer operations are shown, that is used for circuit switching, which is basically a network layer technology that is used in telephony or digital telephony, and that's reserved the network resources for a duration of the call. For a temporary duration, some resources are reserved. Similarly, for multiplexing, we already know from the previous knowledge of multiplexing, that the TDM and multi FDM, a technique for supporting multiple channel on a physical link is used, and that are used in basically the digital telephony. Similarly, packet switching, we already talked in the previous diagram, that how the message is routed from one node to another towards the destination. And for the message switching, similarly, the router operation is basically the functionality of this layer. uh, Input buffers management that are associated with each input to a switch for assembling incoming packets, and output buffers that are also the responsibility of that network layer. Similarly, the table that gives the next hop to be used by this switch for incoming packet, based on the initial content of the table as well as the periodic updates, are result table routing algorithm is used by that algorithm. Other functionality of this layer includes that the delays experienced by the packet in the packet switching network is managed by the network layer, and store and forwarding mechanism is the functionality of this. Similarly, following the queues and dealing with the packet loss, and this is and making a contract between the network layer and the upper layer of the protocol stack. This is again the functionality. Similarly, virtual circuit creation, and also this model does not need any call setup or tear down. Each packet is independent of another, and the switch provides a best effort service model to deliver to the ultimate destination using information in its routing table. So that's basically a summary of this network layer. We already talked about these different terminologies in the course of data communication and network. So for further details, you can just consult this reference. And thank you very much for patiently listening. Take care. Allah Hafiz.